Hey everybody, welcome to another video discussing Unit 2, which deals with matter. And let's talk about Chapter 12 and talk about all the parts of an atom. Now, my guess is at some point in your educational career, you were told about all the different parts of an atom. There's protons, neutrons, and electrons. Now, before we get started talking about protons, neutrons, and electrons and what they are and how they work, one of the things that I want to say is that an atom is the smallest unique part of matter. I mentioned this in one of my previous videos. That doesn't mean atoms can't be taken apart. When you break apart an atom into its parts, it loses the property of whatever atom you're talking about. So if you have an iron atom and you break it up into its parts, into its 26 protons and its 29 neutrons and its 26 electrons, they're not iron protons anymore. They're not associated with the element. Okay? So that's what I want to make sure that I drive home at the very beginning of this, is that atoms, once you break them apart, aren't the element anymore. Okay? So there are, but what are the parts that make up these atoms is that they're called protons, neutrons, and electrons. Okay? And every atom is made up of, almost every atom is made up of some combination of these particles. Okay? The first one is the most important one, and it's a proton. Now, over here, what I'm going to do is I'm going to make a little, chart. Okay? I'm going to put a proton here. Okay? The proton symbol is P+. That's a lowercase p and a plus, because a proton has a charge that is positive. It's kind of a weird table. Okay? But the mass of a proton is 1, and the unit on that is AMU. Okay? They set the mass of a proton equal to 1. So if you have an element that has 1 proton, that proton has a mass of 1 AMU. If you have an element that has 7 protons, that means that there are at least 7 AMU in that element. Okay? And the charge on a proton is 1+. Okay? So let's talk a little bit more about protons, because this is the thing that I want to point out. A proton is what defines the element. Okay? I'm going to call up a periodic table, and we can see on the periodic table that there are 118 elements. What makes element number 1 different from element number 3 is that element number 1 has 1 proton. Element number 3 has 3 protons. There is nothing else that defines an element other than the number of protons. That is it. That is the one thing that you can carry with you for the rest of your life about elements. They are defined by the number of protons. So if I go down to some element that you may not have even ever heard of before, like osmium, okay, that's a really bizarre one. But what defines osmium as being an element? Well, it has 76 protons. That's it, because it's atomic number 76. When you change the number of or if you are doing work and you have the wrong number of protons, you're talking about a different element. Now, electrons, which are symbolized here with an E- for electron, guess what its charge is? If this is minus, this is a 1- charge. So an electron is a counterpart in charge to protons. So 1-, protons are 1+. But here's the really funny thing, is that electrons are super, super tiny, even compared to a proton. An electron is about 2,000 times smaller than a proton. And so because it's so much smaller, we can say that an electron has 0 mass. it has a mass, but it's so small that it doesn't really matter. And so just like if we change the number of protons, we get new elements. Well, here when we change the number of electrons, we make something called an ion. Now there's a future video about ions specifically, but that's the terminology that we need to know. Okay? Is that changing the number of electrons makes something an ion. And then the last part of an atom is a neutron. Okay, so that's a lowercase n, and then we're going to put a 0 there, because a neutron is, as you've probably guessed, is neutral. It has no charge. And the way that I always remembered this, okay, and this is kind of why I put neutron last, is that when you take a proton and a neutron and you shove them together, okay, not physically, but like in your brain, you get a neutron. So when you take a 1 plus charge and a 1 minus charge and you put them together, you get no charge. They cancel each other out. And so we can do the same thing with its mass. Has 1 AMU, an electron has 0 AMU, so that means a neutron has 1 AMU. Now that whole idea isn't entirely scientifically accurate, but I think that it's mentally pretty good in terms of trying to remember what all the parts are and its mass and how it goes, okay? Now, when you change the number of neutrons in something, you make something called an isotope. Okay, I remember isotopes because Homer Simpson was a big fan of the isotopes. He was the guy that celebrated the isotopes all the time. So that's how I always remember isotopes. I don't know why that sticks out, but I always remember Homer Simpson and the isotopes. So, real quick, just to make sure that we know what we're doing here, there's three parts of an atom. Okay, there's protons, electrons, and neutrons. Protons have a mass of 1, have a charge of +1, and if we fiddle around with the number of protons, we end up with a different element than what we started with. Electrons have a mass of 0. They don't weigh anything. They weigh a little bit, but not enough to matter, and it has a charge of -1. And if we change the number of electrons, we make something called ions. Okay, and then we have neutrons, which have a mass of 1 AMU. That's a funny name, AMU, atomic mass unit, and have no charge. And if we fiddle around with the number of neutrons, we have something called isotopes. So if we know that, I think we're well on our way to getting through the next few chapters in the book, and I hope this helps. Have a great day.